My name is Steve Hughes, and I teach math at Grand Canyon University. I'm going to jump in here with you, and we are going to be covering, as I said before, some topics from Domain 5. And our agenda is to cover several questions dealing from the different topics, once again, of statistics, probability, and discrete mathematics. The first one we're going to do is take a look at some principles and techniques of statistics. The question says, determine the correct data type. The distance from your home to the nearest grocery store is. Is it qualitative? Is it continuous? Is it discrete? Is it quantitative? Is it continuous? Those are the things we're asking ourselves. So we want to ask ourselves two questions. The first one is it a number or a label? If it's a number, it's quantitative. It's a label, it is qualitative. Okay, so in this case, it is a number, right? The distance is a number, so it's quantitative. Now, is it continuous or discrete? So we ask ourselves the second question. Can I count it or measure it? So do I count distance or do I measure distance? Right, exactly. We measure distance. So that means it is continuous. So if I can count it, it's discrete. If I can measure it, it's continuous. So this is continuous. So the answer is D, quantitative and continuous. All right, next question. It says, which of the following statements describes the set of data represented by the histogram below? We're trying to compare the mode and the mean, everybody. That's what we're doing. Now remember, in a normal distribution, the mean and the median and the mode are all the same. Okay, the mean, median, mode are all the same in a normal distribution. So this says the mode is equal to the mean is greater than the median is greater than the range is greater, or I'm sorry, the range is equal to the mode. Well, we're not talking about range at all, right? That's not the question. We want to know is the measures of center, mean, median, and mode. That's what we're comparing here. So here's the quick tip for you guys. If the tail goes to the right, if it's a right skew, that tells you that the mean is greater than the median. If the tail is to the left, in other words, left skewed, that means that the mean is less than the median. If it's symmetric, that means that the mean equals the median. So in this case, the correct answer would be what? B, that's correct. The mean is greater than the median because it's skewed to the right. All right, very good. All right, next question. A student scores in the 90th percentile on a test. This means what? Does it mean they scored 90%? Does it mean they scored higher than 90 students? Does it mean they scored higher than 90% of the test takers? Or does it mean 90 students scored higher? This is what I want you guys to think, all right? To avoid any confusion, remember this. Percentile equals percentage of people. Once again, percentile equals percentage of people. So when they tell me that the student scores in the 90th percentile, that means they scored in 90, same as 90% of the people, or greater than 90% of the people, right? So that would be C, that is correct. Okay, so once again, percentile is comparing one person to a group. A percentage is comparing one person with themselves to the score they got on the test. So once again, percentile equals percentage of people. 90th percentile scored higher than 90% of the test takers. Answer is C. All right, next question. A student scores on a multiple choice question with 4 choices. They guess, I'm sorry. What is the probability of guessing correctly? All right, so I want you to think about the formula for percentile. Give me a second, let me grab my pencil. All right, So the probability of an event E is equal to the number of ways the event can occur divided by the number of items in that sample space. All right, the number, that's the cardinality, N of E, N of S, okay? E is the event, S is the sample space. In this case, everybody, what is the probability of guessing? So the probability of guessing, what's the number of ways I could guess correctly? 1. What's the number of items in my sample space? 4. So what's the probability? It is C, 1/4. Remember the formula. The probability of an event is the number of ways the event can occur divided by the number of items in my sample space. All right, let's clear that out. Okay, a card is drawn from a standard deck. What is the probability that the card is a heart or a queen? All right, let's write down the formula for ourselves. Probability of one event A or a second event B is equal to the probability of A plus the probability of B minus the probability of A and B. All right, so the probability of a heart or a queen is equal to the probability of a heart plus the probability of a queen minus the probability of a heart and a queen. All right, everybody, what's the probability of a heart? How many hearts are there? Hearts are one of the 4 suits. That means there are 13 of them, 13 out of 52 cards. All right, what's the probability of a queen? Each of the suits has 1 queen, therefore there are 4 queens out of the 52 cards. And is there a place where you have a heart and a queen? Yes, there is a queen of hearts. How many is that? That is 1 of the cards. So that's 13 plus 4 is 17 minus 1 is 16 over 52. So 16 over 52 is a probability that you select a card which is either a heart or a queen. All right, next. The height of adults in a large group are approximately normally distributed with a mean of 65 inches. If 20% of the adults' heights are less than 62.5 inches, what is the probability that a randomly chosen adult from this group will be between 62.5 and 67.5 inches tall? All right, number one thing I'm going to suggest you guys do to avoid some confusion is to draw yourself a bell curve, okay? Now watch out. My art here is amazing, but we're not focusing on the art, so we'll get through it together. All right. Next, let's put in the mean. All right, here's the mean. All right, let me explain to you the rest of this picture. So it says the mean is 65 inches. Okay, if 20% of the adults are less than 62.5 inches, so here's 62.5. All right, this area right here is 20%. What is the probability that randomly selected will be between 62.5 and 67.5? So first of all, everybody, what's the difference between 65 and 62, right? So 65 minus 62.5 is 2.5, right? So 65 minus 2.5 is 62.5. 65 plus 2.5 is 67.5. So this one is 67.5. And it wants me to find the probability between those two. All right, now here's where symmetry comes in. Because this is symmetric and because these are equal distance from the mean, that means this probability right here must be the same. That means this also must be 20%. So what does that tell us about the distance or the probability between them? This area here, right? This area here. 20 plus 20 is 40. 100 minus 40 is 60. That means this must be 60%. And that would be the answer A, 0.6. All right, that was almost fun, right? All right, good deal. Let's keep going. Let me get rid of this drawing. Let's keep going. All right, next one. What is the binary equivalent of the decimal number 1, 3, 13? First of all, binary is base 2. 13 is base 10. All right, so what we have to do is convert this to base 2 from base 10 or vice versa, right? So here's what we're going to do. We're going to do a shortcut for ourselves. All right, so first of all, let's grab our pencil. And we're going to think about the powers of 2. Notice, everybody, there are four digits here. 1, 0, 1, 1. Likewise, all of them have 4, right? So I need 4 powers of 2. All right? So 2 to the 0, 2 to the 1, 2 squared, and 2 cubed. All right? So 2 cubed is what? 2 cubed is 8. 2 to the 4th, I'm sorry, 2 squared is 4. 2 to the first power is 2. 2 to the 0 power is 1. All right, now what we need to do is go down through here and count and see how it works out, okay? So I want to find the powers that add up to 13. That's what I'm doing. Now notice, I have 1, 2 to the power of 3 right here. That's 1, all right? 1. I have 1, 2 right here, 2 to the power of 4. That's 1. All right, and here I have 1, and there I have 1. So if I used every one of those, I would have to complete every single solitary one of those, right? In other words, I'd have 1 in each place. I would have to add them all together, and 8 plus 4 plus 2 plus 1 is what? 12, 14, 15, right? This would imply 15. That's not the answer I want, though, right? I need to have 13. Okay, so 15 take away 2 is 13. So if I put in this digit like this, 1, 1, 0, 1, that tells me I have 1 with the power of 3, 1 with the power of 2, nothing with the power of 1, and 1 with the power of 0. All right, that would be 8, 4, nothing here, and 1. 8 plus 4 plus 1 is 13. All right, I've just simply worked backwards, right, by adding the powers of 2. All right, so I can't use all of them. That would be 15. I have to eliminate 2. That would be the second one. So my answer here is, which one is that? That's C, 1, 1, 0, 1, just working backwards. Okay. All right, let's go ahead and clear this out. All right, next one. Next one wants me to look at the cross product that says I have 2 sets, A and B. All right, has 3 elements, B has 2 elements. It asks me about the cross product. Everybody, when you think about the cross product, I want you to think about a Cartesian product, or in other words, how many unique pairs, can I make? All right. So I'm looking at multiplication of sizes. All right. So the cross product is the number of elements in set A multiplied by the number of elements in set B. All right. So I could write it like this. I could write the number of elements in set A. Let's write the whole thing out first. A cross B equals the number of elements in A times multiplied by the number of elements in B. All right, in that case, this is 3 times 2, which is 6. So the correct answer is B. Think multiplication. All right, think multiplication when you see the cross product. And you've got it. All right, next one. All right, this one, it says 5 different algebra textbooks, 2 different calculus textbooks, and 4 different geometry books are to be arranged on a shelf. How many different arrangements are possible if the books of each subject must be kept together? This is counting, right, everybody? This is counting. Let's draw ourselves a picture. All right, so the red is going to be the algebra books, okay? I have 5 of those, so 1, 2, 3, 4, 5 algebra books. All right, next. I have 2 calculus books, 1, 2 calculus books, and then I have 4 different geometry books. So 1, 2, 3, 4. All right. Now, if I'm going to start counting, I want to figure out how much I can do in each one, right? I have 5 different textbooks, so algebra books, so I could start out with 5. Then I would have 4, then 3, then 2, then 1, right? Which is 5 factorial. For the the calculus books, I have 2 and then 1, which is 2 factorial. For the geometry books, I have 4 times 3 times 2 times 1, which is 4 factorial. All right, now I could multiply all those 3 together, but if I look down at my choices, I don't have a number that says 5 factorial times 2 factorial times 4 factorial. All right, so what did I forget? All right, what I forgot is that I could arrange these in different orders, okay? I could put these in an order and I could change them if I took this group right here, right? And then this group right here, and then this group right here. I could swap these around. So now think of these 3 as being swapped around in how many different ways? How many different ways could I do that? All right, I could do it 3, 2, 1. So now I can see that my final answer is going to be 5 factorial, 2 factorial, 4 factorial, 3 factorial for the group of each of the different textbooks, right? So that's my conclusion, and my final answer is going to be C. All right, everybody. We have concluded this PowerPoint and these questions. I hope it all goes well for you guys. Thank you for your participation and good luck on your NES exam. Over and out.